Woohoo! I am live. And as you see, I've collected my friends, my sparkly vampire, my Godzilla, a couple of bats, the Bat Brothers. And I am assembled so that I can do some slightly harder equations. We're going to solve some slightly harder equations. And the good news is that we're going to be absolutely fine. It might be a little frustrating. Maybe not. Maybe you guys will look at this and go, oh my gosh, you are so brilliant as a teacher. It makes perfect sense. In which case, life is good. So, shall we get started? The topic today, this is Math 40 Elementary Algebra, Section 2.2, and we are in the second half of it, and this is a concept called clearing fractions and decimals. So basically, the idea is when you're solving equations, you don't need the hassle of fractions and decimals unless you want it. If you want it, go for it. I'm not going to yuck your yum, but I would encourage you to, when you're faced with decimals and or fractions, maybe think about getting rid of them. So what the heck does that mean? Because it would be awesome if we just say, that's fine, I won't deal with decimals. Okay, I'm not going to deal with decimals here. What I'm going to do is I'm going to say, okay, I got rules. The rules say I can add to both sides. I can subtract from both sides. I could also multiply on both sides or divide on both sides. I'm allowed those four things. This is not an impossible decimal, but it is making my brain hurt a little bit. It's just kind of in the way. It's 5/100ths, and it would be written as 5/100 if it were a fraction, or 1/20. But I don't want it there anymore. And so what I'm going to do is I'm going to count. I'm going to see how bad this is. There are 2 digits in this decimal. Now I'm not counting this first 0. This is a placeholder to the left of the decimal. So I start with the decimal and I count how many decimal places that decimal occupies. 2 decimal places. 2 decimal places tells me I should use 100 because there are 2 zeros. If it were 3 decimal places, I would use 1,000. If it were 1 decimal place, I'd use 10. So I'm going to use 100 and I'm going to multiply on both sides. I have to do it on both sides or else I'm not being fair. I'm not being equal. So 100 on the left, 100 on the right. Okay, same thing. And again, if you put your pen or pencil down on the equal sign, you should see 1 on each side, not both on one side, 1 on each. Remember the balance that we're looking for. Okay, so what is 100 times 0.05? Well, if you're not sure, I mean, honestly, I'm a big fan of the calculator. I really am. Try to do things in your head, but if you're not sure, if you want to double check, 100 times 0.05 is, bam, 5. What have we done? We have gotten rid of the decimal. Now it's written as 5, which technically, I mean, you could make the case that it's still a decimal. It's just not written with a decimal point, but you know what I mean. There are no numbers to the right of the decimal point that we have to actually keep track of. They're all zeros to the right of the decimal point. Now, a couple things. Some people worry. They're like, wait, does the 100 have to go in both places? The answer is no, because this is multiplied. So you just do it once, just one time through, no arrows over the top. 2, in order to fluff up this side, which is what we did, we made it bigger, we also have to fluff up this side. Okay, if you're not sure what happens, 100 times 20, delete, equals 2,000, which we also know you've got 20, and whenever you multiply by 100, you just stick 2 more zeros on. So what happened? Well, effectively what I did was I took the old equation and I fluffed it bigger on both sides. As long as you do it on both sides, it's balanced. Okay, so now how do I get to the x, which is right there? How do I isolate x? Well, since this is 5 times x, I'm going to do the opposite thing, which is divided by 5. You got it. And I'm going to do that on both sides. Okay. So cancel the 5. And then over here, I can actually cancel as well. I cancel the 5, and it's going to leave the 5 goes into the 24 times with 2 zeros. X equals 400. Kind of woohoo? Woohoo. Now, I will say this, but I'm not going to write it down because I don't want it to get in the notes and have people be worried. But a more advanced technique, someone would look at this and say, well, this is 0.05. If I multiplied this by 20, I'd get to 1. So you multiply both sides by 20 and you would have finished much sooner. That's an option. Okay, so let's check. Let me see if I can check down here. My original problem, 0.05x equals 20. What if I plug in 400? 0.05 times 400 equals 20. I'm going to check it on a calculator. When I'm doing a check, I don't always trust my brain. Partly because if you're doing a problem, your brain might tell you it's right, even if it's not. So the calculator is not going to be nice. It's going to tell you the truth, even if it's not a nice truth. So let's give this a try. 0.05 times 400 equals 20. We did it. Big old check. I always say woohoo. You don't have to say woohoo. Yes, it's fair for me to point out that the other math teachers think I'm really weird. Well, many of the other math teachers think, the non-weird math teachers think I'm really weird. I do have some weird colleagues. I'm not going to say names, but yeah. So you don't need to write the woohoo part. Other people might think you're weird too. Okay, shall we try another one? You guys ready? You got your support creatures, your Godzilla, your Bat Brothers, your sparkly vampires. We can do this. Dun, dun, dun. I know, everybody looks at that and goes, oh, no. Oh, whaley, whaley, whaley. Okay, we can do it, though. I feel bad for the translator. I have no idea how to spell what I just said. It's in a Scottish brogue. It's from Terry Pratchett, who wrote some wonderful books about a character named Tiffany Aching. I'm going to have to write all these in the notes, I think, for the poor person. Okay, so here we go. That's a lot of decimals we have to deal with. 0.105x plus 0.06 times the quantity 20,000 minus x equals 1740. Now here's the thing. Do you have to clear the decimals? No, you don't. You can just do this problem exactly as written. A lot of people are perfectly fine with that. Go for it. There's another thing that says that you could go ahead and multiply this through before you clear decimals. I'm also not going to do that. The style I'm going to follow is I'm going to clear these decimals right off the bat. I'm just going to get rid of them first thing. So to do that, I'm going to count. So I'm going to count 1, 2, 3. I've got 1, 2, 3 decimals, or 3 decimal places. And then this one, 2 decimal places. And this one doesn't have any decimal places that we wrote in. So 3 versus 2, take the worst. Look for the worst. So you're looking for, oops, there we go. The most, or the, that's supposed to say worst. It says whoopst. I don't know what whoopst means. Again, big thanks to the people who are very generously captioning this, because they are probably having a bit of a rough day today. Okay, worst. But I really appreciate it. Thank you so much for your hard work. It makes it possible, so thank you. So you want to look for the most or the worst. So 3 decimal places, 2 decimal places. Let's go for 3. So if we're going to choose 3 decimal places, we need a number with 3 zeros. Right? Remember the 3 zeros? We did 2 zeros last. Right there, 3 zeros. Okay, so what am I going to do with the 1,000? Well, I'm going to multiply everybody by 1,000. And this is going to make some of the numbers really, really large. And that's just the trade-off. So 1,000 times 0.105x plus 1,000 times 0.06 times the quantity 20,000 minus x equals 1,000 times 1740. Now, we've gotten to the first question a lot of people have, which is, wait a minute, don't you have to multiply inside? And the answer is, this whole big mess right here is one term. You only need 1,000. What's going to happen is we're going to combine these two numbers together, and then they're going to use the distributive property. And so it's kind of like grabbing the number on its back and carrying it into the parentheses. So the 1,000 is going to go into the parentheses, just not first. Okay, 1,000 times 0.105. We take the decimal point and we're going to move it 3 spots. So I get 105x. Okay. Now, the 1,000 has 3 zeros, so it's going to move the 0.06 3 spaces. 0.06. So it's going to go 1, 2, 3. So we're going to end up with 60 instead of 6. And then over here, this is a whole number already. So we're going to get 1,740,000. So 1,740,000. Okay, so what does this look like? 105x plus 60 times the quantity 20,000 minus x equals 1,740,000. Now, no decimals. You might decide that this was not worth it. Some people look at this and they're like, you know what? I'd much rather deal with the decimals, in which case go for it. You can do it either way. However, this is just another technique you can use if you get overwhelmed with decimals. We cleared the decimals. That's what we've done. And now I'm going to work with this, and I'm going to take the 60. And the 60 is sneaky. The 60 is the 0.06 times 1,000. So the two of them are buddies now. It's a buddy movie, and they're going to go distributing through. So they go to the 20,000, they go to the x. So I've got a couple things to do here. And again, when it comes to decimals, and especially a lot of zeros, I personally have the kind of brain that gets a little bit scrambled. So again, I'm going to double check my work. I know what I think the answer is going to be, but for this right there, I'm going to double check, and I'm going to count the zeros very carefully. 1, 2, 3, 1, 2. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So 4 over here, 1 over there, and then 6 times 2 is 12. So 12 with 5 zeros. 105x plus 12 with 5 zeros minus 60x equals 1,740,000. Woohoo. Okay, now variables. I've got 2 variables here. I'm going to bring them together. So 105x minus 60x. I'm going to combine these two, and I get 45x plus 1,200,000 equals 1,740,000. Okay, now what? Now I need to get the x by itself. So what I'm going to do is I'm going to take this 1.2 million and I'm going to subtract it from both sides. I've got the paper at the ready. So then I get 45x here. And when I take 1,740,000 and subtract 1,200,000, I end up with, you got it, 540,000. And let me write that on this paper. This is to continued. This is to be continued. Okay, never mind. Okay, next up, solve this. Oops, sorry, let me get it straightened out. There we go. 45x equals 540,000. This is 45 times x, so to solve for x, I do the opposite thing, which is dividing. X equals, now it doesn't look like it's going to go in evenly. Let's check. Oh, it does. And I get x equals 12,000. Okay, are we done? Yay! No, we're not done. Oh, no. What's the last thing you do with an equation? You've solved it. Life is good. Everyone is like, yay, you solved it. Thank you. You saved us. And you're like, you're welcome. Yes, I know. I'm a hero. Oh, I'm so awesome. Yes, I'm a mathematician and I solve math problems. And that's why everyone loves me. And the townspeople are like, yay, we love you. We're going to make you our king, give you lots of chocolate. Okay, so I'm going to go ahead before I get carried away with this imaginary town where everyone loves me because I do math. I'm going to go ahead and write out the original problem as much as I don't want to, because this is the downside is that you have to check in the original problem. So 0.105 times 12,000 plus 0.06 times 20,000 minus 12,000 equals question mark 1740. Okay. 0.105 times 12,000 equals 1260 plus, and then this part I can do in my head, 0.06 times 12,000, sorry, 20,000 minus 12,000 is 8,000. And the question is that equal to 1740? So I've got to do this multiplication. Notice I've got a 6 and an 8, so I'm expecting to see something with 48 in it. 0.06 times 8, 1, 2, 3, 8,000 is 480. So we've got 1260 plus 480, which equals, oh my goodness, you guys are not going to believe this. Look at that. Oh, wonderful day, wonderful day. Happy checks, 3 checks because I'm very excited. Woohoo. So there's the good news. We finished it. The bad news is we're at almost 19 minutes. So, wow, those are some not easy problems. Next up in the very next video, we're going to do some 2 problems with fractions. Yep. But the good news is once we do it, you'll be like, oh, okay, I can totally do it. It's not my favorite thing necessarily, but we can do it. Woohoo, that's the goal. Math on, guys. Math on.